Hello everyone. Today we are going to see some questions from AMC 10A. This paper is conducted on 7th Feb 2019. So without wasting time, let us start. Let us see the first question. First question in front of you is what is the value of 2 power 0 power 1 power 9 plus 2 power 0 the whole power 1 the whole power 9. Okay, so here first of all you must understand the concept of powers. Like here we have 2 power. Okay, now the power is 0 the whole power 1 upon 9. So you can start with bracket by bracket. So 2 power, now 0 power anything, 0 power anything, 0 power anything means 0 multiplied by any number. It is going to be 0 only, so it become 2 power 0 plus, now here we have 2 power 0. Now 2 power 0 is 1. So now 1 power we have 1 and then whole power we have 9. So 1 power anything is 1. So that means we have 2 power 0. Now 2 power 0 is 1 and this is 1 and 1 plus 1 is 2. So the answer for first question is 2. Okay. Now let us move to question number 2. Question number 2, here we have what is the 100th digit of 20 factorial minus 15 factorial. Okay, have you understood the question? What is the 100th digit of 20 factorial minus 15 factorial? I will give you some time, let us say 1 minute. You try this and then we will see the solution. Okay, now let us try. What is the 100th digit of 20 factorial? Now if we analyze this 20 factorial, this 20 factorial means it is 20 times 19 times 18 times 17 and so on. Okay, so if you see that how many times, actually I have to see that how many times I get 5 and how many times I will get 2 as the factor for this 20 factorial. So when I say 20, 20 is 2 times 5. Okay, so I get 2 times and 5 one time. Then again in 18 I will get 2. Then in 16 I will get 2. They are all in multiple. So I have lot of 2's. Okay, now I will check how many 5's I have. In 20 I got 1 5. 5 into 4 I can say. Then in 15 I will get one more 5. Then in 10 I will get one more 5. And 5, it is 5 only. So 4 times I got 5 and more than 4 times I got 2. So 5 into 2, 5 into 2 is 10. So that means 10 into 10 into 10 into 10. 4 times at least I am getting 10 in multiplication. So 10 times 10 is 100, times 10 is 1000, times 10 is 10,000. Okay, that means here when I expand 20,000, I will definitely get a number which is more than 10,000. Okay, now it will be multiple of 10,000. This is also right, it is multiple of 10,000. So as it is multiple of 10,000, that means okay, your unit place, tens place, 100 place and thousands place, they are all 0. Okay, so they are all 0. Now when I consider 15, So in 15 also at least 3 times I am getting 5. In 15 it is 5 into 3, in 10 it is 5 into 2, and in 5 it is 5 into 1. That means 3 times at least I am getting 5, and more than 3 times I am getting 2. So again 10 is present here 3 times, so that means 1000. So in 1000 I have unit place 0, tens place 0, and 100 place 0. So I see that in 20 factorial I have unit place 0, tens place 0, 100 place 0, as well as thousands place also 0. And in factorial 15 factorial at least I have unit place, tens place, and 100 place 0. So if I see the difference of if I see the difference of this, and I will see what is present in the 100 place, so definitely it is 0. So here my answer, okay, here my answer is 0. So what I said, that you have to explain here, and you can write. Okay, fine, good, very good question. Now let us move to third question. Now here in third question we have Anna and Bonita were born on the same date in different years, n years apart. Last year Anna was 5 times as old as Bonita. This year Anna's age is square of Bonita's age. What is n? So Anna, again, once again you read the question. Anna and Bonita were born on the same date in different years, n year apart. So the age difference between Anita and Bonita will be n years, and this will continue for like every year. I will say that when uh, if I look 5 year from now, then also the difference between their age is going to be n. Now what is said that last year Anna was 5 times as old as Bonita, and this year Anna age is square of Bonita's age. So what is n? So again you take 1 minute and try to understand how you can solve this problem. Okay, now let us continue. So as here it is said that last year Anna was 5 times as old as Bonita. So I will say let last year age of Bonita is x years. Let last year age of Bonita is x year. So therefore last year age of Anna. So last year age of Anna will be going to be 5 times. So it will be 5 times x. Now this year we have age of Bonita. It will be x plus 1, and age of Anna, it is going to be 5x plus 1. Now in problem we have mentioned that this year Anna age is a square of Bonita's age. So this year Anna's age, that is 5x plus 1, this is square, that is it is x plus 1 the whole power 2. Now let us simplify this. We get 5x plus 1 equal to x square plus 2x plus 1. Okay, so this will give us x square equal to 3x. Okay, or x square minus 3x is 0. So therefore we will take x common and x minus 3 will be 0. So therefore either x will be 0 or x minus 3 will be 0. So therefore x will be 0 or x will be 3. Okay, now x, what x represent? It is represent age of Bonita last year. Now the value of x cannot be 0. If I consider x 0, then 5x will also become 0, which is not possible, right? So x cannot be 0. So as x cannot be 0, so therefore x is equals to 3. So therefore either I can find present age of Bonita and Anna and then find difference. N is the difference between the ages. So I will say that the difference in ages of the difference in their ages, it is 5x minus x, which is 4x, and 4x is what? 4 into 3. 4 into 3 is 12. So difference between their ages is going to be 12. So what is n? The n is 12. Okay, now if you wanted to cross check, you can put the values of x and you can see what is their ages last year and what is their ages this year, and you check whether the age of Anna this year is square of age of Bonita this year. This question is a simple one. Now let us see the fourth one. Question number 4 here is, a box contain 28 red balls, 20 green balls, 19 yellow balls, 13 blue balls, 11 white balls and 9 black balls. Okay, so a lot of balls are here. What is the minimum number of balls that must be drawn from the box without replacement to guarantee that at least 15 balls of the single color will be drawn? Now this is the problem related with probability. Okay, again you think about this problem and then we will discuss together. Okay, so what is your answer? Have you got the answer? Now here the question, what is the minimum number of balls that must be drawn from the box without replacement to guarantee that at least 15 balls of single color will be drawn. Now we have to make sure that 15 balls of the single color will be drawn. Okay, so for this we can say that suppose 14 balls 14 balls of red color are drawn, and 14 balls. Now why I am choosing 14 balls of green color? Here green color is drawn. Similarly 14 balls of yellow color is drawn. Now there are only 13 blue balls. Okay, so let us consider that all the 13 colors of blue ball is also drawn, and 11 whites are drawn, and 9 blacks are drawn. 11 whites and 9 blacks. Okay, now if you draw all these balls, then the next ball when you draw, it will be either red or green or yellow. And as it is red, if it is red, then you will get 15 red balls. If it is green, you will get 15 green balls. And if it is yellow, you will get 15 yellow balls. Have you understood? So this is a combination of minimum number of balls, okay, that will guarantee you that there is 15 balls of a single color. So now let us add this. Okay, because here if you see, now there is, after drawing till here this 9, okay, the next ball you draw, that will be 15th ball of the same color. So I have 14 times. How many times? 3 times we have done. Then plus we have 13, plus we have 11, plus we have 9, plus we have 1. Okay, so that means 76. So if you draw 76 balls, okay, then it will be guaranteed that you have drawn 15 balls of the same color. So the option B is the right one. Again, this is, I will say that very good question. This is question number 4. Now let us see question number 5. Question number 5, here we have, what is the greatest number of consecutive integers whose sum is 45? What is the greatest number of consecutive integers whose sum is 45? Now you have to make sure that sum is 45, and you have to find greatest number of integers. What is the greatest number of consecutive integers whose sum is 45? So you can take negative numbers also, right? So you can take negative numbers as well as positive numbers, and you have to make sure that your sum is 45. So as I want a greatest number, okay, then in that case, greatest number of consecutive integers whose sum is 45. So 0 if I consider at the center position, okay, the negative numbers on this side and the positive numbers on this side. Okay, suppose I take minus 44 here, then we have minus 43, and so on, and here I have minus 1. Similarly, I will have 1, 2, 3 and so on till I have 44. So all these numbers, they will cancel and I will get result as 0. Then the next number 45. Okay, so here if I start with minus 44 and I will end with 45, and if I add, then this much portion they will cancel out each other and 45 will remain. So my addition will become 45. So now the question is how many these numbers are. So 45 minus of minus 45 minus 44 I will say. So this will give you 89. Okay, and when I find the difference between this and this, then one number is not included, so I will add plus 1 to it. So there are 90 integers, consecutive integers, that if I add, I will get sum as 90. Okay, now this is quite interesting and a logical one also. Okay, now move to sixth question. So as we are moving, the questions are becoming tough and tough. How many of the following types of quadrilaterals does, okay, so here the problem I have not pasted. For how many of the following types of quadrilateral does there exist a point in the plane of quadrilateral that is equidistant from all four vertices of the quadrilateral? So I have to find one point in the quadrilateral which is equidistant from all the fours. So here if you see a square, okay, then there is a point in square which is equidistant from all the 4 points, right? A square definitely is the answer. Then we have a rectangle that is not a square. Okay, if I take a rectangle and if I take a point on its diagonal, okay, then it is at equal distance from all the 4 points. So here the concept is that the diagonals should be of equal length. Then and then only we can say that it is of equal distance from all the 4 vertices. Now in a rhombus, the diagonals are not equal. In a parallelogram that is not rectangle again, or a rhombus, then also the diagonals are not equal. An isosceles trapezium, that is not a parallelogram. Now in case of isosceles trapezium, for isosceles trapezium it may possible that diagonals are of equal length. Now when diagonals are of equal length, then definitely the 4 vertices are at equal distance from the point of contact. So if suppose rhombus is something like this, and if I draw a diagonal like this and this, okay, no, it is not, because diagonals are not bisecting. Okay, they are not bisecting. So here, is there any other figure? Here now square and rectangle are fine. Okay, so answer could be 2. Rhombus is definitely not, and parallelogram is also not. Means suppose in case of square, one more way we can consider that this is suppose square, and if we consider the point of intersection of diagonal, okay, so I will say that okay, this length, and this length and this length are equal. That means if I draw one circle by considering this as radius, then my circle will be like this. So this circle will inscribe this particular quadrilateral, that is square or rhombus or something. Okay, now isosceles trapezium. Now in case of isosceles trapezium, one more thing, that if the corners are lying on the circle, then sum of opposite angles is going to be 180. So it is possible in square and rectangle, that is fine. Now what about isosceles trapezium? Is the sum of opposite angles is 180. That means this angle plus this angle is their sum is 180. So answer is yes, because here in isosceles trapezium, this angle same, this angle same. So anyway x plus y is going to be 180. So whether I add this x and this y, it is going to be 180. So an isosceles trapezium is also one shape, okay, in which I can get one point which is equidistant from all the 4 vertices. So here answer will be 3. Sixth question was a tricky one. Okay. Now seventh problem. Seventh problem, if we see this question number 7, two lines with slope half and 2 intersect at 2 comma 2. What is the area of the triangle enclosed by these two lines and the line x plus y equal to 10? So two lines with slope half and 2 intersect at 2 comma 2. What is the area of the triangle enclosed by these two lines and the line x plus y equal to 10? Okay, again a challenging one. Here what we can do, we can try to draw the graph. Okay, that will be better. Now as the two lines have the slope half and 2 and they intersect at 2 comma 2, so what I can say that equation of lines we can find out. So one line will be y, it is y minus, equation is what, y minus y1 is equals to m, that is slope, times x minus x1. Okay, so this is one side. We will simplify it, we will get 2 times y minus 4 is equals to x minus 2. So therefore x minus 2y, x minus 2y is equals to minus 2. X minus 2y is equals to minus 2. This is equation 1. And the other equation is, here we have y minus 2 is equals to 2 times x minus 2. So therefore we have y minus 2 is equals to 2x minus 4. So therefore we have 2x minus y, 2x minus y is equals to 2. Second equation. So I have for a triangle I have one equation, x minus 2y equal to minus 2, other 2x minus y equal to 2, and third they have already given. Third equation is x plus y is equals to 10. This is third equation. Okay, now we have to find the two lines is given. What is the area of the triangle enclosed by these two lines and line x plus y equal to 10? So now I have to find out area. Okay, so let us first draw 3 lines. Suppose these are the three lines. One line here I have x minus 2y equal to minus 2. Other line, suppose I have 2x minus y is equals to 2, and third line I have x plus y equal to 10. Okay, now here the point of intersection is given 2 comma 2. Okay, I can find out point of intersection here and point of intersection here. Okay, 1 minute. Better you try and find out these 2 points of intersections. Okay, so have you got the point of intersection? Let us try. Now here these two equations we will solve. So for solving these two equations, one equation is x minus 2y is minus 2. Other equation is x plus y is equals to 10. So what we will do? We will see the difference. Here if I see the difference, then it is minus 3y, and here it is minus 12. So y is 4. So as y is 4, I will take y 4. Now as y is 4, x is going to be 6. So 6 comma 4 is 1 point. Similarly here I have equation 2x minus y is 2 and x plus y is 10. Here if I see, I have 3x equal to 12, x is equals to 4. So now here x is 4, the y is going to be 6. Okay, so now these are the three vertices of triangle. Now I have to find area. Now to find area, if the vertices are given, then area is given. Area is given by the formula. We have a formula for area which is half times it is 1 by 2 times. Here the x coordinate, any x coordinate we take, like 2 we take, then it is y2 minus y3. That means we can say that 6 minus 4, plus then I will take another x coordinate which is 4, then it is 4 minus 2, and then I will take the third x coordinate which is 6, then it is 2 minus 6. Okay, so here the area which we get 2 times 6 minus 4. Now 2 times 6 minus 4, it is 2, 2 times 2 is 4, then plus it is 2 times 4 is 8, and then minus, here it is 4 times 6 is 24. So actually for area we have to take them in mod because area is not negative. So minus 20 plus 8 is, or 20 minus 8, if we see, it is 12. 12 divided by 2 is what? 6. So area here, the required area is going to be 6. So option C is your answer. Now here for a triangle, if the coordinates are given, then we can find area by using the formula. Now formula, if I say, it is half 1 by 2 times x1 y2 minus y3 plus x2 y3 minus y1 plus x3, it is y3 y1 minus y2, y1 minus y2. This is the formula for area. So this is 7th question. Okay, now 8th one. Question number 8. Question number 8 is little lengthy. Now here if we see question number 8, the question given is, the figure below shows line L with the regular infinite recurring pattern of squares and line segments. How many of the following four kind of rigid motion transformations of the plane in which this figure is drawn, other than the identity transformation, will transform this figure into itself? Some rotation around a point on the line L, some translations in the direction parallel to line L, the reflection across line L, and some reflection across a line perpendicular to line L. Okay. Read question once again and then try to figure out the answer. Have you understood the question and options? How many of the following four kind of rigid motion transformation of the plane in which this figure is drawn, other than the identity transformations? Now, some rotation around a point on line L. Now, if I rotate about some point on line L, will I get the similar kind of pattern? So, answer is no. Some translations in the direction parallel to the line. Now, if there is a translation parallel to this line only, okay, then I will get the similar pattern. The reflection across the line L. If there is a reflection along the line L, if there is a reflection along the line L, no, the pattern will be reversed, and some reflection across the line perpendicular to line L. If I do reflection around, I think this problem is like we are not able to identify the problem perfectly, so better we avoid this question, as here we have negative marking. So better, if you don't figure out the question, better leave that question. Okay, so here I think I must leave this question. Maybe after solving other problems, if we get time, we will come back. Now, what is the greatest 3-digit positive integer n for which the sum of first n positive integer is not a divisor of the product of the first n positive integer? Okay. Again, read the question. What is the greatest 3-digit positive integer n? I have to find greatest 3-digit positive integer n for which the sum of first n positive integers for which the sum of first n positive integer. Now, when I say sum of first n positive integer, that means it is sum of 1 plus 2 plus 3 plus so on till your 3-digit positive number, for which the sum of first n positive integer is not a divisor of the product of first n positive integers. Okay, so again the problem is challenging one. Now, the product of first n positive integer is like 1 into 2 into 3 into 4 into 5 till into n. Now, when I add all these numbers, I should not have this as a divisor. So, what concept we apply? What will be our thinking? Let us try this problem. Okay, so what is the greatest 3-digit positive integer n for which the sum of first n positive integer is not? So first, if I see about the sum, so the formula for sum is n into n plus 1 divided by 2, and formula for product, the formula for product is n factorial, because it is 1 times 2 times 3 times 4 times and like that until n time. So the product is n factorial and the sum is n into n plus 1 divided by 2 factorial. Now um, the question is that this n into n plus 1 divided by 2, okay, should not be a factor of this n factorial. Means I should find n in such a way that this n factorial upon n times n plus 1 divided by 2. Now divide by 2, so that 2 we will move here in numerator. Okay, so here 2 times n factorial divided by n into n plus 1, okay, should not be any integer. So what is the greatest 3-digit positive integer n for which the sum of first n positive integer is not a divisor, is not a divisor of the product of the first n positive integer. So first of all you can see that this 2 into n factorial I can write as n into n minus 1 factorial, and here it is n into n plus 1. So this n we cancel. Now I want n in such a way that 2 times n minus 1 factorial should not be divided by n plus 1. Okay, so that means n plus 1, now this n plus 1 is definitely greater than this n minus 1. So this n plus 1 should be a prime number. Okay, if this n plus 1, what I am saying, I myself is little confused. I think what I'm saying is perfect. This n plus 1 should be a prime number. Now if this n plus 1 will be a prime number, then definitely it is not going to divide this n minus 1 or any number which is less than n minus 1. Right, what I'm saying? Like if 7 is a prime number, now 7 can divide 14 or its multiple only. Okay, if I take the product of 6 and or 5 and the numbers below that 5, okay, they are never going to cut this n plus 1. So my n plus 1 should be a prime number. Here n plus 1 should be equal to prime. Now in this option I want n plus 1 prime. So 995 plus 1 is not a prime. 996 plus 1 is a prime, right? 996 plus 1 is 997 and 997 is a prime number. So that means your n should be 996. Okay, your n should be 996. 997 will be prime number, and when in denominator I have 997, but in numerator the all numbers are 996 or less than 996. Even I will say that 995 and number less than 995, then definitely they are never going to be divided by 997, and so the option B is the right one. Okay, again ninth question was a tricky one. Last problem for today. Let us see the last problem for today. A rectangular floor that is 10 feet wide and 17 feet long is tiled with 171 foot square tiles. A bug walks from one corner to the opposite corner in a straight line, including the first and the last tile. How many tiles does the bug visits? So 10 feet by 17 feet. So suppose this is the shape, something like this. This is 17 feet and this is 10 feet. And 17 and the 170, so total how many tiles are there? 170 tiles are there like this. Okay. So here 17 and like this I have different boxes. Okay. So at the end I have one box here. Now there is a bug which starts from here and it goes in a straight line. So definitely it must go like this. We have to find out how many tiles does it cross. What I have to find out? How many tiles does it cross? So it is visiting this first and last tile. Think about it. I think here we have to draw the diagram and then only we will be able to understand the problem. Actually, if you see uh, horizontally, okay, horizontally it is crossing all the 17 tiles, right? Each tile in the horizontal line will be crossed. Like the first tile is crossed here. Similarly, in the second row, might be second will be crossed. Here I can see that the second and third is crossed. And similarly, as I go below, then next two are going to be crossed. So like this, if you see, you will find that in horizontal, if I see there are 17 tiles that will be crossed. Now, vertically, how many tiles are crossed? The better option for this problem is that we will draw all the boxes and then we will count them and that will give you the answer. So here I have drawn these and you can see that here one box, here two, here 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 and 26. So total 26 boxes are crossed. Now if you find some analytical answer for this question, let me know. Otherwise, this is one of the simplest and shortest way of solving this problem. So how many? 26. Okay, total boxes will be crossed Okay, when the bug will move from one corner to the opposite corner. Okay, so these are the first 10 questions. Now here in this question, this last one was little lengthy if I am doing this diagram. And yes, one more problem. This question number 8 I haven't understood at all. So we can leave that question. Rest all questions we have done it. Okay. Okay, fine. So I will see you in the next class with a few more questions from the same paper. Till then, take care. Bye bye.